Okay, number 11 says, given this position function, find the average rate of change of position. So the key words here to recognize are average rate of change. Anytime you see that, you should be thinking msec, the slope of the secant line, which is our old slope formula, rise over run. See how that works out in a couple contexts. Let's say I'm looking at this first example. I have the average rate of change of g of x. So I would translate that as g of b minus g of a over b minus a. Notice I just stick the x values and then the y values plugged into the function itself. There's no derivatives involved here because this is the average rate of change. If I wanted the derivative, I would see the word instantaneous rate of change. So that's when I know I need to find f prime, or in this case, it would have been g prime. So if it said, on the other hand, something a little more complex, find the average rate of change of f prime of x, then I would just do f prime of b minus f prime of a over b minus a. Again, you're just plugging in to here. You're not taking the derivative. If it says find the average rate of change of position, well, position is s of t, so I do s of b minus s of a over b minus a. See the pattern? If it said find the average rate of change of velocity, try it yourself. Pause the video. So you would have done v of b minus v of a all over b minus a. Nice. Now in this last case, notice it doesn't say rate of change. I just say find the average acceleration. So unless you are given the acceleration function, the only way that you could use msec here is to cross out the word acceleration and replace it with rate of change of velocity, because we know that v prime of t equals a of t. So acceleration is the rate of change of velocity. I'm just using that definition so that I can apply my msec formula now. Now that I see the words average rate of change, I can use my msec formula, except it's going to be using v in my formula. So actually, asking you to find the average acceleration is the exact same thing, just with different words, as saying find the average rate of change of velocity. I'll use v of b minus v of a. So if I'm given a graph of f, I'll just do the same thing, using the y values here and here over the x values. And if I'm given a table, let's say this said find the average rate of change of velocity, then I do v of b minus v of a over b minus a, where I get v of b from here. V of a would be monkey, and then b minus a are the x values, or the times. Okay, so for number 11, they want me to find the average rate of change of this position function. First thing I'll do is underline average rate of change and make a note to myself. I'm looking for msec. I'll immediately follow that up with my formula. But it wants the average rate of change of position. So instead of f of b minus f of a, we're not dealing with some random f function. We want s instead. And our a and our b in this case are 0 and 2. So we're going to write s of 2 minus s of 0 over b minus a, which is 2 minus 0. On the left side, I'm writing msec of our position function, msec sub s. So let's find s of 2 first. Well, here's the s function, so we simply need to plug it in. So that's going to be 2 times 2 minus 1 squared times 3 times 2 plus 2. 2 times 2 gives me 4, minus 1 is 3, times 3 times 2 is 6, plus 2 is 8. That's 9 times 8, which is 72. Now let's find s of 0. So plugging it in, I get 2 times 0 minus 1 squared times 3 times 0 plus 2 squared. This leaves me with a negative 1 squared times 2 squared. So that's going to be 1 times 4, which is just 4. So now we can go back and plug in our values. S of 2 was 72. S of 0 was 4. And it's all over 2 minus 0, which is 2. 72 minus 4 simplifies to 68, divided by 2 is 34. So our average, so on the left side you could write MSEC sub S, or you could just say average rate of change of position. So the average rate of change of our position function is 34 units per minute, for example. Now they didn't give me units here, so 34 is fine, but keep in mind that on the AP exam you will be given units, so you might write like kilometers per hour.